Now student, here I am going to explain you about the factors affecting the speed of sound in gas. So as you all know very well, yesterday I discussed that this is the formula of the speed of sound in the gas. So what is the effect of pressure? If in the gaseous medium is there is a pressure variation, then how does it affect the speed of sound? Okay, so see, when you are going to see the effect of pressure, you have to keep other things constant. Otherwise, you cannot determine through which quantity the speed of sound is varied in the medium. So that is why we have taken at constant temperature. Temperature you have kept constant in the medium, okay? And gamma you all know very well, Cp over Cv. So when you are taking a constant temperature, so you know for the gas Pv is equal to constant. From here V can be written as m upon rho, mass upon density of the gas. So when you will substitute this value uh, in this formula in place of V, m by rho, so it will come out to be constant. Since mass of the gas remains constant, so when you will take it in the denominator of this constant, so it comes out again a constant. Okay, so P by rho comes out to be constant. So if P by rho constant means if you will change the pressure, density of the gaseous medium or air also varied. As you all know very well, when the sound wave travel or longitudinal wave travel in the medium, when there is a variation in the pressure, the density also be changed. In the medium of rarefaction, density becomes more, density become less. In the region of compression, pressure is more and density will also be more. So if you will increase the pressure, density automatically in the gaseous medium increases. When you will decrease the pressure, density also decreases. So this ratio comes out to be constant. Okay, so it means when you will substitute this value over here, you will find there will be no effect on the speed of sound in the gaseous medium. Okay, now the second is what? Effect of density. So effect of density, as you are observing that V is inversely proportional to square root of density. If you are taking that we have a two gases and we are taking the same temperature of the gas, pressure of the gas. So when the two gases are at the same pressure, then what will happen? When you will apply this formula, V is equal to under root rho by P by rho. And here gamma is also constant because gamma is particular kind of gases for diatomic, for triatomic, this is also constant. Okay, for N2, for O2, the value of gamma will be 1.4. So if you are taking gamma constant for two gases and P constant, then V1 by V2, the ratio of velocity for the two gases is equal to under root of rho 2 upon rho 1. So this is about the effect of density. Now come to the next. What is the effect of humidity? Effect of humidity, as from the same formula, V is equal to under root gamma P by rho. V is inversely proportional to rho. Now when the moist air is present in the atmosphere. Moist air means what? During the rainy season. Moist air will be present there. Means we have a water molecules, water vapor in the atmosphere. So water vapor, if there is present in the atmosphere, so density of the dry air decreases because water molecules they will take place in place of the air molecule. So but moist air has density about 0.8 kg per meter cube at STP and dry air that is 1.293 kg per meter cube at STP. So the dry air has more density compared to moist air. So that is why rho for the water vapor or moist air will be less as rho for the dry air. So that is why according to this concept inverse proportionality, the speed of sound in the moist air is more than the speed of sound in the dry air. Now the next is the effect of temperature. We know that rho is equal to m by v. Okay, v is equal to, from here v is equal to m by rho. If I am taking 1 mole of a gas, so when you are taking 1 mole of a gas, then PV is equal to RT is the formula. And when you are substituting the value of V from here m by rho in this formula, so P m by rho is equal to RT. P by rho, this is the ratio which included in the speed of sound. Okay, this will be equal to RT upon m from this formula. Now m will come out over here. So p by rho will be RT upon m. Now substitute the value in the speed of sound. V is equal to gamma p by rho. You will be getting that V is equal to gamma RT upon m. Okay. So if the molecular mass and the R and gamma is constant for a gas, so how does the speed of sound be affected when the temperature varies? So when the temperature varies in the atmosphere, then speed of sound is directly proportional to under root of T. So if T increases, V also increases. Understood? So this is the effect of temperature. So if you are taking that two different temperature at 0 degree Celsius, V is directly proportional to 0 plus 273, because here we are taking T at 0 degree Kelvin. When you are going to convert it, so it will become that is T plus 273. So that is why temperature at 0 degree plus 273 it come out to be in Kelvin. Similarly, at T degree Celsius, the velocity at T is equal to T plus 273. So the ratio comes out to be Vt over V naught is equal to this. In this way, you can calculate the particular temperature at which the speed is given in the atmosphere. Okay. Now the next is what? Next is the effect of wind. Effect of wind means what? Suppose this is the direction of propagation of the sound wave. Okay, with velocity v. So v is the velocity of the speed of sound in this direction. But wind can blow in this direction also, wind can blow in this direction also, wind can blow in this direction also. So here we have taken that W is the velocity of the wind blowing at a particular angle with the direction of the speed of sound. So theta is the angle between the direction of the propagation of the sound wave, and W is the direction of wind blowing. So you will take the two components of the W. So W cos theta is the component of the wind velocity along the direction of the speed of sound. So we are going to take the W cos theta in the direction of the V. So what will be the, if the two velocities are in the same direction, then what will be the resultant velocity of the sound? The resultant velocity of the sound will become V plus W cos theta, because this wind blow affect the speed of the sound. So V dash is the resultant velocity of the sound. This will be equal to V plus W cos theta. Okay. Now we are going to see the effect. If theta is equal to 0 degree, theta is equal to 0 degree means what? W and V both are in the same direction. V and W both are in the same direction. So when both are in the same direction, so cos 0 degree is equal to 1. So resultant velocity will come out to be V plus W. It means when the wind is blowing along the direction of the speed of sound, then resultant velocity of the sound increases. The sound velocity appear to be increased. Now if theta is equal to 90 degree, there will be no change in the speed of sound, because cos 90 is equal to 0. If the wind is blowing in the direction just opposite to the direction of the speed of sound, velocity of the sound is this, and velocity of the wind is this. So theta is equal to 180 degree. So when both are anti-parallel to each other, then V dash is equal to V plus W cos 180 degree. What is the value of cos 180? Minus 1. So V dash, any resultant velocity of the sound, V dash is equal to V minus W. It means the speed of sound V dash in this condition appear to be decrease. It will be decreases. So these are the uh, effect of the factors affecting the speed of the sound in the gaseous medium.